Okay, welcome. This is organic reactions. So make sure you have your notes, also your reference tables to P, Q, and potentially R. Okay, well, definitely table R. All right, here we go. Given the reaction, this is an example of. Okay, so let's take a look at what we have, and then we can figure out what we're forming, and then we'll go from there. So before we do, our four choices are fermentation, which is production of an alcohol, saponification, which is production of a soap, hydrogenation, which is and esterification, which is formation of an ester. So let's see what we formed. So what is this? Well, if it's, let's see, is it an alcohol? Let's go there. Whoops. Alcohols have an OH group, and esters have the C double bonded O to a single bonded O. So those are those two. And let's see if we can go from there. So I see a C double bonded O to a single bonded O. So that is an ester. So this is esterification, formation of an ester. And we also have talked about how an ester is formed by this, which is an organic acid, and this, which is an alcohol, which looks creepy because it's got OH the backwards way, but it's still there. In which organic reaction is sugar converted to an alcohol and carbon dioxide? So production of alcohol is fermentation. Base your answer to the following question of the organic reaction below. So what's going on? So it looks like, let's see, we've just got an alkene because we've got a double bond adding a bromine. And so bromine looks like this. Diatomic. And so if you look here, we've broken the double bond here and opened up spots for the bromine. So that's called an addition reaction. We're adding additional spots for the bromine to come in. Another one about fermentation, you're producing alcohol and carbon dioxide. Production of soap, look for the one that has soap in it. So saponification has soap just mixed up. So formation of a soap is saponification. The reaction that joins thousands of small identical molecules to form one very long one. Small identical molecules, one very long molecule. That is polymerization. Super long carbon chains. Polymerization. Again, esterification is formation of an ester. Fermentation is formation of alcohol. And a substitution, that's not what's being described. Okay, number 7. I see ... right there, which of course I crossed off. ... means keeps going. So we're adding all these double bonds, double bond, alkene, 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 and then we just have this super long carbon chain. That's polymerization. Just adding, and the key here, look for those ... It just means it's going on and going on and going on. Number 8, which organic product is formed by the reaction below? So we have two products, obviously. This is the product side. So which one is organic? Well, whichever one contains carbon. So this is what we want. So make sure you don't care about that. So what is the name of this? We have all single bonds, so it's ane. And so look, that's going to eliminate everything. So we have 1, 2, so this is going to be ethane. But we have a bromine added on, so this is bromoethane, which you didn't actually need to know that as long as you can notice that we have all single bonds, which gets rid of the ene, ine, and the benzene. Another one about fermentation. Sugar, the products of a fermentation of a sugar are ethanol and carbon dioxide. Think about all the yeast burping it back up. Which organic reaction produces rubber and plastics? Well, those are polymers, long carbon chains. Again, esterification, formation of an ester or fats. Saponification is soap. Fermentation is alcohols. Okay, so here we have, there's no pictures, but we could certainly draw it if you want. C2H6. And you know those are H's at the end. And then we've got a Cl2. Now, can you just, for the sake of space, I'm not drawing in all the valence electrons for chlorine, but know that they are there. And over here we have C2H5. Now one of these is a Cl, and now we have an HCl. which if you wanted to draw it, okay. So it looks like it's not addition, because addition would have one product. Although saturated hydrocarbons are all single bonds, so this is an alkane. So it can't be an unsaturated hydrocarbon because it is an alkane. And it can't be a substitution with unsaturated because we have an alkane. So it's a substitution involving a saturated hydrocarbon. So think about it. We've got the game here and we've got the bench. It's like, coach, put me in the game. So one of the CLs goes into the game and we sub out a hydrogen. So this is in from the bench and this is in from the game. So that's a substitution, choice 3. See, I know sports ball. Which organic compounds are often used to create fragrances for the perfume industry? So again, this is Granny Esther, old Granny Esther. All right, and that's just a definition that we should know. Number 13, which reaction best represents complete combustion of ethene? So first of all, do we have ethene? Yes, we do. To combust, you need a hydrocarbon, and this is old. We've talked about this for carbon. There's an R there. Plus oxygen, and you got to have CO2 and H2O. So the only one that fits that is choice 3. The other ones, let's look. Choice 1 is an addition because we've got one product. Looks like we've got another addition for choice 2. And hey, choice 3. Yeah. Which is an addition reaction? So addition reactions happen when you have an unsaturated, so an alkene or an alkyne, that you break the double or triple bond, find extra spots, and you'll have one product. So, and I hate how this broke up like this. This is CH3, COO, CH3, plus H2O. So that looks like you've got two products. We're not adding them together. And actually, if I were to go down here, CH3, COO, CH3, what is that? That's old Granny Esther. That's a formation of an ester, so that's esterification. Looks like this, C2H6 plus Cl2. Look, that's a substitution. They put a Cl in and take an H out. Oh, C3H6. So C3H6. 1, 2, 3, 4, 5, 6, 7, 8. It can't be that. So it can't be an alkane. So if I oh no. If I did this, well, I didn't want all of that. Okay. 1, 2, 3, 4, 5, 6. Yeah, okay. So here we have C3H6 with an alkene, and we're adding H2. Yeah, this is it. We're breaking an unsaturated hydrocarbon and finding extra spots. This is going to be fermentation, formation of an alcohol and carbon dioxide, which will undergo a substitution reaction. Substitution reactions happen with saturated hydrocarbons, so single bonds. So who, and again, to go back to the tables, to figure out the general formulas of an alkane saturated, you'd need to have double the hydrogens as carbons plus 2. So let's go back. So a substitution reaction is CH4 an alkane. So double the carbons would be 2 plus 2. Yeah, this is an alkane. This is double the carbons alone. So this is an alkene. So that's not going to do substitution. That would do an addition. This is double and this is double. So those are all unsaturated. You want a saturated substitution reaction with all single bonds. All right, what's going on here? C2H2. That looks like double the carbons and then minus 2. So this is an alkyne. If you don't believe me, go ahead and try table Q. And it looks like we are going to break that multiple bond and form one product that's called an addition reaction. Finally, when hydrocarbons burn completely in an excess of oxygen, oh, this is combustion. What are the products of combustion? Carbon dioxide and water. Okay, if you have any questions, please reach out. Thank you.